Hey guys, welcome back. In the last lesson, we looked at the need for a messaging platform and saw why Kafka is a good fit in big data ecosystems. And we even compared Kafka with another messaging broker, which is RabbitMQ. In this lesson, our goal is to introduce you to some core concepts and terminologies in Kafka. Here is a very simple illustration of what happens in Kafka. Someone produces a message and someone consumes it. That someone who produces a message is called the producer, and that someone who consumes the message is called the consumer. In Kafka, the producer does not care who the consumer is. All the producer does is place or publish the message on a topic, and any consumer who is interested in the message needs to subscribe to the topic and consume the messages in the topic. What is a topic? Let me give an example to help you visualize. Think of the conveyor belt in the airport where you stand patiently to collect your luggage. The conveyor belt is the topic, and the luggages in the conveyor belt are the messages. The guy who is placing the luggage from the aircraft onto the conveyor belt is the producer, and you at the end of the conveyor belt is the consumer. Clear? Conveyor belt here is the topic. As the passenger waiting next to the conveyor belt, you're only interested in your baggage. It would be weird if you pull all the baggages from the conveyor belt and call it yours, right? In contrast, a consumer in Kafka listening to a particular topic can consume all the messages in the topic or could consume a selected few. In most instances, it would consume all the messages in the topic. In the baggage claim area, there are many conveyor belts, right? But you as a passenger is only interested in the conveyor that is assigned to your flight. Similarly, in a Kafka cluster, there could be multiple topics, and a consumer in Kafka is interested in a specific topic. If you've been to a busy airport, you might have noticed that a conveyor belt might be assigned to multiple flights. So, baggages from more than one flight can come through one conveyor belt. This is also possible in Kafka. A topic can have multiple producers and multiple consumers. As a passenger waiting to pick up your luggage, all you see is the conveyor belt in front of you. The guy who is placing your baggage on the belt does not care about you specifically. All he does is place the baggages from the aircraft onto the belt, and the baggages magically end up inside the airport. If you are in a busy airport like JFK or Heathrow, you can imagine the complexity involved in bringing the luggages from the multiple aircrafts to the passengers. Both the passengers and staff placing the luggages on the belt don't worry about the complexities. Similarly, in Kafka, the producer places the message onto the topic and the consumer consumes it. Both participants don't care about the complexity involved in bringing the messages reliably from producer to the consumer. The complexity is handled by Kafka, and both producers and consumers don't have to worry a bit about the complexity. Similarly, in Kafka, the producer places the message onto the topic and consumer consumes it. Both participants don't care about the complexity involved in bringing the message reliably from producer to the consumer. The complexity is handled by Kafka, and both producers and consumers don't have to worry a bit about the complexities. We see Zookeeper in the illustration here because Kafka needs a small Zookeeper cluster to operate. Now let's get into some specifics. In our illustration, a producer could be Twitter producing tweets, or it could be one of your applications in your organization producing a constant stream of information, or even a standalone program could be a producer. Very simply, a producer is anything that produces a stream of messages. A consumer again could be a program or any application which is interested in consuming the messages produced by the producer. A message in Kafka is nothing but a key value pair with a timestamp. The value in key value pair has the data or information we are most interested in. It could be as simple as a string, or nested information like JSON, or even a custom object serialized in Avro, etc. Okay, now we know what a producer is, what a consumer is, what is a topic, and also what is a message. What is the Kafka logo in the middle? What does it represent? Kafka is usually deployed in a clustered setup, that is, a collection of nodes running Kafka. Each node in a Kafka cluster is referred to as a Kafka server or simply broker. Kafka cluster is responsible for bringing the messages from the producers to the consumers reliably. In a big data environment where you could get thousands of messages a second, This job could be very complex, especially when the volume of messages is high and reliability is very important. As said, Kafka uses a small zookeeper cluster to perform various coordination activities between the nodes in the cluster. Zookeeper helps in managing which nodes in the Kafka cluster are alive or dead. It is used when there is a need to elect a leader between the Kafka brokers. It helps store metadata information about the topics and replicas, etc. More on this in the upcoming lessons. There are too many concepts to explore in Kafka. Why don't we explore Kafka with a use case so it is easy for us to understand? Let's say we would like to get all the tweets that are sent by anyone in the world in real time. So we ask Twitter to publish all the tweets into our Kafka cluster, specifically into a topic named Twitter topic. Our Kafka cluster is a 10-node cluster, meaning we have 10 brokers. Soon we realize Twitter, with its massive infrastructure, is publishing 500 million tweets per day in our Twitter topic. Right off the bat, we will see a couple of issues. With one consumer, Twitter is publishing faster than we can consume. So we need to increase the speed of our consumption. But we see a more pressing problem. Only one node in our 10-node Kafka cluster is busy. Its CPU and memory is peaking, and there is not much activity with the rest of the nodes in the cluster. Let's understand why this is happening first before we worry about the consumption speed. To understand why the load is heavy in one node and not on the rest of the nodes, we need to understand an important concept in Kafka: partitions. When we create a topic, behind the scenes, the messages are published in the topic are stored in one partition in the same order as they were received. Think of partition as a queue, or like a log where new messages which are coming in are added to the end of the partition. The information or messages in the partition are saved in the disk and will be retained by default for 7 days by Kafka. Here is the crazy thing about partition. One partition cannot span multiple nodes. That is a problem, right? If all the tweets from Twitter end up in one partition and that partition can reside on only one node, this would mean the consumer has to read from the same node where the partition resides. In our illustration, the messages from the producer end up in partition 1 on node A, meaning the producer writes the messages onto the partition 1 in node A directly. Consumer will then consume the messages from node A. This will eventually make node A extremely busy when compared to the other nodes in the cluster. Agree? So we need our topic to support multiple partitions. And with Kafka, we can configure our topic to have more than one partition. Now let's say we configure our topic tweet topic to have 5 partitions. Now any incoming tweet is placed in one of the 5 partitions, and each partition could potentially be stored in a different node. Here in our illustration, we are saying partition 1 resides in node A or assigned to node A, partition 2 in node B, partition 3 in node C, so on and so forth. Multiple partitions can reside on one node as well. At runtime, Kafka will decide which is the best node to host a partition. With multiple partitions and multiple nodes involved, both writing and reading to and from partitions is distributed, thereby the load is distributed across the cluster. Twitter is still pushing a lot of messages so fast and our single consumer is struggling to keep up. What do you think we can do to increase the speed of consumption? Come on, put on your big data hat and try to answer. Great answer. Why are we just running one consumer? Let's try to run more than one consumer. Okay. When you start another consumer in Kafka by default, you will realize that both consumers you have now are processing the same exact messages from the topic. That is not what we wanted, right? In fact, it is a big problem. If both consumers are consuming the same set of messages, one, we are not increasing the speed of consumption, and two, we are duplicating the data. Bottom line, we don't want the same tweet to be sent to more than one consumer. Why is Kafka sending the same tweet to multiple consumers? Because from Kafka's point of view, it thinks both consumers are not related in any way. So we need to let Kafka know that the consumers are related. And it is super easy to do. We will create a consumer group and will associate our consumers to the consumer group. When Kafka sees consumers from the same group, it makes sure that a single message is not sent to more than one consumer. Every consumer in a consumer group is assigned a partition, and only one consumer could consume from a partition, which means messages that end up in a partition is consumed by the assigned consumer. We have 5 partitions in our illustration. Let's say we have 3 consumers in our consumer group 1 that you see right below here. Then at runtime, consumer 1 might be assigned to partitions 2 and 5. Consumer 2 might be assigned to partition 4. And consumer 3 will be assigned to partition 1 and 3. A message, when it enters a topic, will be assigned to one of the 5 partitions based on the key in the message using a partitioner logic. Since we have assigned only one consumer to a partition, there won't be any overlap in messages that are being consumed between the consumers in the consumer group. So no data duplication between the consumers inside the same consumer group. At the same time, this also gives us parallelization in consuming the messages, which means we will be able to process the tweets at a much faster rate. Problem solved. Here in the illustration, we also have another consumer group 2. In this consumer group 2, we have only one consumer. Since this consumer is in a different consumer group, this consumer has no association with the consumers that you see down below in consumer group 1. And since there is only one consumer in consumer group 2, all the partitions will be assigned to this one single consumer. Makes sense, right? You can think of consumer group 1 as your inventory application. And you can think of consumer group 2 as another application, application XYZ. And both applications are interested in the same messages that are posted by Twitter. Okay. Believe it or not, in this short lesson, we covered a lot of core concepts in Kafka. We understand the role of producers and consumers. We understand what is a message and what is a topic. And more importantly, we understand the importance of partitions and consumer groups. In the next couple of lessons, we'll focus more on how reliability and fault tolerance is handled in Kafka. See you in the next lesson.